section 7.4, problem number 5. I'm going to solve this one by substitution. I'm going to take that second equation and I'm going to add y squared to both sides. And I'm going to add 1 to both sides. So that's going to give me 3x squared plus 1 equals y squared. Now I'm going to take this y squared, which is really 3x squared plus 1. They're equal to each other. And I'm going to take this y squared out and replace it with 3x squared plus 1. So I'm using substitution. So that gives me the original 2x squared plus 5. Now I'm taking out the y squared and I'm putting in its place 3x squared plus 1. And that's supposed to equal 39. Now I distribute this 5. So I get 2x squared plus 15x squared plus 5 equals 39. That gives me 17x squared plus 5 equals 39. Subtract 5 from both sides, I get 17x squared equals 34. Divide both sides by 17. I get x squared equals 2. Now square root both sides. Remember, when you square root both sides, you have to bring a plus or minus with it. So you get x equals a positive square root of 2, and x equals a negative square root of 2. All right, now we want to find y, so we're going to plug that in. So I've got 3x squared minus y squared equals a negative 1, and I'm going to put in a positive square root of 2. So I've got 3 times the square root of 2 squared minus y squared equals a negative 1. So then I get the square root of 2 squared is just 2, so I get 3 times 2 is 6 minus y squared equals a negative 1. Subtract 6 from both sides, and I get a negative y squared equals a negative 7. Divide both sides by negative 1, and I get y squared equals 7. Square root both sides, and I get y equals plus or minus the square root of 7. So I could do the same thing with the negative square root of 2, but it's going to give me the exact same answer. So I have 3 solutions. I have the square root of 2, the square root of 7. I have a negative, actually I have 4 solutions. So I have square root of 2, square root of 7, negative square root of 2, positive square root of 7. Then I have square root of 2, negative square root of 7, and then I have negative square root of 2, negative square root of 7. Now, just let me show you algebraically what's happening here. We haven't learned how to graph an ellipse or a hyperbola. We haven't learned anything at all about them, but a hyperbola looks like this. That's a hyperbola. And an ellipse looks like this. And I wanted to show you this so that you could actually see that that's why there would be 1, 2, 3, 4 solutions.